Now to the huge solar storm hitting the Earth's atmosphere. It's millions of miles away, but the eruptions on the sun are bringing the northern lights to regions that rarely see them all over the world.
It's 93 million miles away, but the violent eruptions on the sun.
We may face our last days on Earth as the most powerful solar storm approaches in over 2 decades. This storm did more than light up the sky. It can destroy everything from Elon Musk's satellites to our power grids and GPS systems. Now, we have to ask ourselves, what if this is just the beginning of even more terrifying storms? Let us explore how we can shield our lives and our tech from the sun's fierce power. The solar storm that shook the world. These unusual and widespread appearances were the result of an immense group of sunspots, an area 16 times larger than Earth, which emitted a series of X-class solar flares and coronal mass ejections aimed directly at Earth. The magnetic storms that followed were of the highest intensity, ranked G5, reminiscent of the intensity last witnessed during the 2003 Halloween storms. As the Earth was bathed in ethereal lights, the impact of the solar storm was felt beyond just the visual spectacle. Technology, both in space and on the surface, faced significant disruptions. Among those affected was Elon Musk's Starlink. Reports emerged of the satellites facing substantial strain, although they continued to function amid the storm. On the ground, the effects were more pronounced, with power grids experiencing fluctuations, GPS services losing accuracy, and high-frequency communication systems facing interruptions in various locations. This disruption highlighted the delicate balance between human technology and nature's unpredictable forces. The severity and timing of these solar events hinted that the solar maximum, the peak of the sun's 11-year activity cycle, might be arriving earlier than predicted. If these disturbances were a prelude to what is expected at the peak, it suggested a need for preparedness for potentially more severe impacts. The solar storm served as a vivid reminder of the planet's vulnerability to solar phenomena. Despite human advancements in technology and a growing footprint in space, the forces of the sun remain a formidable power, capable of causing widespread technological disruptions at a moment's notice. Recently, the sun underwent a significant magnetic field reversal, signaling a likely increase in geomagnetic storms in the near future. These storms are expected to enhance the visibility of auroras, creating dazzling displays of light across the night sky. However, they also pose a risk to the stability of radio communications and electrical grids. Auroras, those mesmerizing light shows, are not just for visual enjoyment. They serve as a natural indicator of the ongoing interaction between the solar wind, a stream of charged particles ejected by the sun, and Earth's protective magnetic field. This celestial interaction, while beautiful, can have severe repercussions. The disturbances are triggered by explosive phenomena on the sun's surface, such as solar flares and coronal mass ejections. These events eject vast amounts of energy and particles into space, which travel to Earth and disrupt its magnetic field. This disruption results in currents that can overload and even damage power grids and communication networks. As the time approaches for the sunspots to face Earth once more, questions about readiness and resilience come to the forefront. The anticipation of how existing infrastructures will cope with another wave of solar activity is a topic of significant concern. The ongoing cosmic interactions highlight the fragile balance between natural celestial processes and human technological reliance. Each display of auroral beauty is a reminder of the immense forces at play in the universe and the challenges posed to Earth's technological stability. The recent solar storm was caused by a sunspot called AR 3364. Sunspots are darker, cooler areas on the sun's surface. While the normal temperature around them is about 5,800 Kelvin, sunspots cool down to between 3,000 and 4,500 Kelvin. When AR 3364 first appeared, it seemed normal, but soon grew significantly. It expanded to 200,000 kilometers, or about 125,000 miles, making it 16 times wider than Earth. This growth isn't just a small change. It's a major event that shows just how powerful and dynamic the sun can be. The expansion of AR 3364 can disrupt Earth's satellite communications and even affect our power supplies, highlighting the strong influence the sun has on our daily technology. Although it started off looking ordinary, the rapid and large-scale change in AR 3364 serves as a reminder of how small and exposed Earth is in the vast universe. The ongoing activities of this sunspot group are closely watched by those who study space weather, leading us to think about how prepared we are for these solar disturbances. The sun marked another cycle with notable activity. At the forefront was AR 3364, a large sunspot identified early by NOAA's Space Weather Prediction Center. This sunspot was flagged for potential high activity, and it lived up to those expectations. Over the course of a single week, AR 3364 produced a staggering 75 M-class flares and 10 X-class flares, contributing to half of the X-class flare occurrences of the year. Solar flares are powerful bursts of radiation that emanate from the sun, shining brightly across various wavelengths. These events are not just brief sparks. They can illuminate the sky for hours and release enormous amounts of energy. The energy unleashed during these flares is equivalent to the detonation of millions of hydrogen bombs. Remarkably, the light from these flares takes a mere 8 minutes and 20 seconds to travel the 93 million miles to Earth, showing the raw power and speed of these solar phenomena. Next, we explore how the sun's fiery power impacts our world. The hidden threat of solar flares. The presence of these flares is not just a spectacle for those with telescopes. They impact Earth in profound ways. The intense energy from the flares has the potential to disrupt satellite operations, communication systems, and even electrical grids. These disruptions highlight the fragility of modern technological reliance, illustrating how deeply intertwined human life has become with the functionality of its inventions against the backdrop of cosmic forces. While some may marvel at the beauty and intensity of these solar events, others see them as stark reminders of the sun's dominance and unpredictability. Each flare serves as a lesson in humility, showcasing the might of nature and the thin thread upon which technological stability hangs. As each burst of solar radiation races across the solar system, it underlines the precarious balance between earthly achievements and cosmic occurrences, reminding humanity of its place within the broader universe. Solar flares are classified from weakest to strongest: B-class, C-class, M-class, and the most potent, X-class. Each class marks a tenfold increase in power, much like stepping up from a tiny spark to a robust explosion. B-class flares are the quiet ones, barely noticeable and often ignored unless one is particularly focused on solar activity. They hardly cause a stir beyond the confines of solar observatories. C-class flares are somewhat stronger, yet they still lack the power to make any significant impact on Earth. They are usually only of interest to those who spend their days monitoring solar phenomena, providing just enough activity to keep data logs busy, but not much else. Moving up the scale, M-class flares begin to show their teeth. These are strong enough to interfere with radio communications around the Earth's poles, creating disruptions that can last from a few minutes to several hours. They also pose a radiation threat to astronauts in space, serving as a harsh reminder of the sun's ability to affect human technology and health. The X-class flares are where the real drama unfolds. These massive bursts of solar energy can cause serious problems, from disabling satellites to overwhelming power systems on Earth. Scientists track these flares closely, knowing that each one has the potential to send technological systems into chaos and affect billions of lives. These flares highlight the delicate balance between Earth and its fiery star, reminding everyone of the sun's dominant presence in the solar system. However, it is crucial not to confuse solar flares with their more dramatic relatives, coronal mass ejections, CMEs. While a solar flare is essentially a sudden flash of brightness and energy in the sun's atmosphere, a CME involves a massive release of magnetized particles into space. This event is far more forceful and can have even more severe consequences for Earth. CMEs can propel billions of tons of particles into space at high speeds, potentially leading to catastrophic disruptions if they collide with Earth's magnetic field. CMEs are capable of triggering geomagnetic storms that can disrupt electrical grids, disable satellites, and even cause radiation storms that are dangerous to astronauts and high-flying aircraft. The distinction between these two solar phenomena is critical for understanding the various risks posed by the sun's activity. As the sun continues its cycle, it pays little heed to the concerns of those on Earth, following its own rhythm and processes, while humans can only observe and prepare for its next outburst. The sun, a relentless powerhouse in the center of the solar system, often goes through periods of magnetic instability. During these times, its magnetic fields experience a sudden and forceful realignment. This dramatic process releases vast amounts of solar material into space, hurtling at speeds that can exceed 1,000,000 miles per hour. Known as coronal mass ejections, or CMEs, these phenomena can take anywhere from a few hours to 3 days to reach the vicinity of Earth. These events are not merely visual spectacles. They are enormous bursts of gas that extend into the vacuum of space, overshadowing the less intense solar flares in both magnitude and potential impact. Upon their journey through space, these massive clouds of charged gas eventually encounter Earth's magnetic field. This meeting, though frequent, never fails to disturb the delicate balance of the planet's magnetic environment. The force of the collision sends ripples through Earth's magnetic fields, generating powerful currents that propel charged particles towards the polar regions. There, in the high atmosphere, these particles interact with gases to create the mesmerizing lights known as auroras. These lights, with their vibrant hues, paint the polar skies in shades of green, pink, and violet, offering a breathtaking spectacle that is both beautiful and haunting. However, the beauty of these celestial events belies their potential for disruption. The power of CMEs extends beyond the creation of auroras. These solar emissions have the capacity to interfere with satellite operations, disrupt communications, and even cause extensive power outages. The technological infrastructure upon which modern society so heavily relies can be severely affected by these solar storms. The reliance on satellite navigation and communication systems makes society vulnerably interconnected, so that a single strong CME could trigger a cascade of technological failures. Now, let's delve into the sun's magnetic chaos and its effects on Earth. The delicate balance of celestial events. The persistent dance between these solar forces and Earth's defenses forms a complex relationship. While humans marvel at the stunning displays in the sky, there lies an underlying tension. Each brilliant display of the auroras is a reminder of the sun's power to not only create beauty, but also to unleash chaos on the world's technological systems. Thus, every observation of these natural phenomena is tinged with an awareness of the delicate balance between enjoying their beauty and preparing for their potential threats. This duality marks the relationship between Earth and the tempestuous solar activities that shape much of our space weather. When the sun gets active, it puts on quite the show with its magnetic field shifts, leading to significant and sometimes disruptive space events. These aren't just simple light shows, but powerful occurrences that can affect space weather and have unique impacts on planets like Earth. Solar flares pop up as intense bursts of light, sudden and bright, hard to miss. Coronal mass ejections, however, appear more daunting. Huge swirling clouds of magnetized particles that slowly move through space. This round of solar activity started on May 3rd with an X-1.6 solar flare, a significant event, but just the beginning. Over the next 2 days, 2 more X-class flares occurred, each one a serious release of energy, suggesting that the sun was getting more restless. Then the following day, the sunspot region really showed its strength by releasing an even larger X-4.5 flare, an enormous outburst of energy. Shortly after this, the first coronal mass ejection was spotted, a massive cloud of charged particles making its way out from the sun. These events remind us of the sun's ability to not just light up the sky, but also to cause disturbances. The effects of these solar outbursts are extensive, impacting satellite functions and electrical grids on Earth. They are not just to be watched and enjoyed from afar, but are significant influencers of both technology and natural systems. As these huge phenomena, both flares and CMEs, make their way through space, their roots and impacts are watched closely by those who know how much can be affected by each solar event. On May 8th, another coronal mass ejection emerged hot on the heels of a significant M8.6 solar flare. adding another chapter to the ongoing solar activity. The drama did not pause there. The next day, May 9th, saw the emergence of two X-class flares, each giving birth to its own CME, further crowding the space with energetic outbursts. By May 10th, the tally had reached 4 CMEs, all hurtling toward Earth, an escalation that caught the attention of many observers. The last 3 of these solar eruptions, notable for their fierce and rapid travel, decided to merge into a larger, more dominant mass, dubbed a cannibal CME. This name stems from their behavior of overtaking and merging with each other, driven by their differing speeds and converging paths. This phenomenon is not merely a display of celestial dominance, but provides critical insights into the interactions of solar forces. Upon reaching Earth, these CMEs did not pass unnoticed. Instead, they met with Earth's magnetic field, which stood ready to deflect their forceful charge. This magnetic interaction is not just a simple bounce-back effect. The magnetic fields of both the storm and Earth intertwine, crafting an intricate dance that culminates in the creation of a magnetic funnel. Through this funnel, charged particles from the Sun are guided down towards Earth's poles. The descent of these particles along the magnetic field lines illuminates the skies with the auroras, a natural light display known for its breathtaking beauty. These lights, often seen in the polar regions, are not just a visual treat, but a transformation of potentially disruptive solar energy into a mesmerizing spectacle. It's a testament to Earth's ability to not only protect itself, but also to craft beauty from cosmic chaos. The constant battle between Earth's magnetic field and the powerful solar winds from the Sun creates the well-known aurora. When solar winds hit us, they stretch the magnetic fields on the daylight side of the pole to their limits. It's not a magical or puzzles event, but more like a forceful cosmic interaction where our magnetic defenses are pulled and twisted. At some point, these stretched magnetic fields can't hold anymore and snap like an overstretched elastic band. What follows is quite a scene, though fairly predictable. Charged gases from the solar storm follow the broken magnetic paths like debris swept along in a flood. They head toward the poles, but only appear as the nighttime aurora. This event, often described in poetic terms, is simply Earth's way of dealing with the solar onslaught. It's a clear case of cause and effect at a cosmic level, where every action has a reaction, and everything pushed up must come down. The lights, although beautiful, are just the visible outcomes of these cosmic fights, displayed across the sky like spray paint on a natural backdrop. Moving on, we examine the subtle yet powerful threats from solar storms. The hidden cost of solar activity on Earth. Auroras, often seen as simply green, reveal a much more dramatic story when they burst into large red displays. This change in color isn't just a treat for those looking at the sky, it shows the powerful energy at work far above us. The belief that auroras are only green simplifies the complex science happening in our atmosphere. The range of colors we see, from deep blues and purples to rare, widespread reds, depends on the particles involved and where they collide with the Earth's atmosphere. Blue and purple lights occur when solar particles hit molecular nitrogen up to 62 miles or 100 kilometers high. It's a display of solar particles and gases mixing, visible under the right conditions. Green auroras come from similar interactions where these particles meet oxygen, but at higher altitudes of about 100 to 300 kilometers, or 62 to 186 miles. However, the red auroras that sometimes light up the sky happen during particularly strong solar storms. In these cases, high-energy particles go deeper into the Earth's atmosphere, affecting not just the higher oxygen, but sometimes lower levels too. This creates a striking red across the sky, showing the intense forces that are constantly at play. These geomagnetic storms are not merely a spectacle of nature's beauty. They pose real threats to the lifelines of modern civilization, the electrical power grids and satellite networks. As the storm engages with the Earth, it generates currents known as geomagnetically induced currents, or GICs, which stealthily travel through the veins of our power systems. These currents flow through power lines and transformers, the silent carriers of electricity to our homes and industries, and begin their subtle yet destructive dance. The transformers, crucial components in the distribution of power, are particularly susceptible. They can become overloaded and overheat, a process akin to a clogged artery in a living organism, straining under pressure until it fails. This overheating can lead to multiple cascading failures. Transformers might shut down, safety devices could activate erroneously, power lines could bear too much load, and generators, the heartbeat of our electrical supply, could falter and fail. This vulnerability raises questions about the resilience of our technological systems against nature's might. Despite our advances, the infrastructure that supports our daily lives proves repeatedly to be inadequately prepared for such solar assaults. The dependency on an aging grid system, which could metaphorically be seen as playing a risky game of chance with nature, exposes significant weaknesses. The cycle of disruption followed by repair is a costly one, not just in monetary terms, but also in the resources and time expended to restore normalcy. Each incident lays bare the urgent need for discussions on strengthening and updating our electrical infrastructure. Yet these necessary conversations often fall to the wayside, eclipsed by other pressing concerns of the day. The fragility of modern infrastructure often comes to light during solar disturbances, which have historically caused significant disruptions. One notable event occurred in 1989 in Quebec, Canada. A severe geomagnetic storm struck, leaving 6 million people without electricity for a staggering 9 hours. This incident was not unique in its impact. As of the latest observations, a sunspot group labeled AR 3364 had made its way behind the sun's expansive disk. Although temporarily out of sight, its potential for disruption remains a concern for experts who monitor these solar phenomena. The absence of visibility does not equate to an absence of risk. Instead, it represents a brief pause, a moment of calm before the potential resurgence of solar activity that could once again challenge the stability of earthly technologies. Each instance of solar interference, from blackouts to satellite failures, serves as a stark reminder of humanity's enduring susceptibility to the forces of nature. Despite significant advancements in technology and a growing understanding of solar dynamics, the threat of sudden solar outbursts continues to loom large. These occurrences not only highlight the immediate impacts on daily life and technological operations, but also stress the ongoing need for improved protective measures and systems designed to withstand the capricious nature of solar activity. The understanding and mitigating solar risk continues, with each event providing valuable lessons in preparation and resilience. Emissions from the sunspot group known as AR 3364 will pose no threat to Earth for the coming 2 weeks. Yet as the celestial dance continues, AR 3364 is expected to re-emerge and face Earth once more. Given its track record, there's a high likelihood that this group could resume its disruptive activities once it comes into view again. Before it disappeared on May 11th, AR 3364 demonstrated its volatility by releasing powerful solar flares, an X1.8 followed by a much larger X5.8 flare, with the latter triggering a coronal mass ejection. This burst of activity hints that AR 3364 may still be far from settling into tranquility. Let's focus on a particular sunspot that could disrupt our modern world. Preparing for the next solar event, deadly lessons from the past. The nature of sunspots like AR 3364 often embodies a pattern of erratic behavior. As the current calm lingers, the lingering question remains whether this sunspot will kickstart another round of disturbances or if it will fade into a quieter phase. The evidence, however, leans towards a continuation of solar fireworks. Historically, this sunspot has displayed a flair for the dramatic, much like a seasoned performer who revels in the limelight. Its potential to interfere with Earth's geomagnetic field and disrupt communication networks remains a pressing concern. As such, the next few weeks could witness not merely theoretical predictions, but tangible disruptions. Observers and scientists alike monitor these developments closely, understanding that the behavior of sunspots can significantly influence technological and natural environments on Earth. The cycles of activity and dormancy are not just astronomical phenomena, but have real-world implications for satellite operations and communication. As AR 3364 prepares to re-enter the Earth-facing stage, anticipation builds, not just among the scientific community, but also among those who rely on stable technological infrastructures. The hope is for minimal disruption, but the preparedness for more solar outbursts is equally prioritized. Solar flares were increasing in frequency, and AR 3364, a monstrous sunspot, was a clear testament to this trend. Visible from Earth without any aid, its vastness was comparable to the sunspot that triggered the Carrington event in 1859, which was notorious for igniting fires in telegraph stations and brightening the night skies with auroras that reached as far south as the Caribbean. The presence of such a large sunspot served as a stark warning about the fragility of modern technology, which could be severely disrupted by solar activity. The potential for satellites to be knocked out, communications to falter, and power grids to collapse was a genuine threat. Despite this looming danger, there was an undeniable thrill tied to these celestial events. The raw and untamed force of nature was a humbling reminder of humanity's smallness in the universe. As observers tracked AR 3364, its similarities to the destructive sunspot of the past evoked a sense of caution and awe. Although the odds of experiencing another event of Carrington's magnitude were low, the potential implications were enough to stir a blend of fear and fascination. Despite advances in understanding solar phenomena, humanity's capability to mitigate these cosmic forces remained limited. Observers were left to merely watch, speculate, and prepare, facing the unpredictability of space weather with a mix of resignation and intrigue. The telegraph system stood as the epitome of electrical innovation, a modest but revolutionary technology for its time. Fast forward to the present, where the landscape of technology has dramatically transformed. Society now leans heavily on more complex systems like satellites and GPS, which are integral to the daily functions of global communications and navigation. These systems, though advanced, depend on a consistent and stable magnetic environment to operate effectively. This dependency has unwittingly exposed a vulnerability to solar disturbances, highlighted by phenomena such as sunspots. One notable example is AR 3364, a sunspot capable of significant solar activity that poses a real threat to the magnetic stability necessary for today's technology. The reliance on sophisticated electrical systems is woven deeply into the fabric of modern life, making any potential disruptions a serious concern. A significant solar event, akin to the historical Carrington event of 1859, could trigger widespread havoc. Such an event today could disrupt not only telecommunications, but also essential services that maintain public safety, health, and economic stability. Economic assessments paint a grim picture of the potential fallout. The estimated financial impact of a major solar disturbance could range from 60 cents to $2.6 trillion in the United States alone. This stark projection underscores the precariousness of the current technological setup, where a large-scale solar event could result in severe economic and societal disruptions. The threat extends beyond the creation of beautiful auroras across the sky. It encompasses the tangible risks of widespread technological failures and infrastructure breakdowns. One could envision scenarios where satellites cease to function, communication networks are interrupted, and electrical grids are overwhelmed. These consequences are vast, affecting more than just the immediate environment, but potentially halting economic activities and plunging cities into darkness, reminiscent of pre-electric times. A comprehensive video was developed to shed light on the solar cycle and its direct impacts on earthly technologies and daily life. This video does not serve as a mere cautionary tale, but as a critical educational tool aimed at preparing populations for what might soon be a common occurrence. It delves into the underlying science of solar activities, outlines their potential effects, and suggests measures to safeguard essential electronic systems. The video serves as a resource for those seeking to understand the magnitude and scope of the risks associated with solar storms. By educating themselves, individuals can be better prepared for a future where solar disturbances disrupt more than the tranquility of the night sky. The intent of the video is to inform and equip people with the knowledge and strategies necessary to mitigate the impacts of these solar events. Outro. Are we truly prepared for the catastrophic potential of a massive solar storm? Like, comment with your thoughts, and subscribe for more insights on this critical topic.